I introduce our today's speaker, Dr. Arvind. Dr. Arvind is presently associate with the Center for Science and Environment, New Delhi, India. Principal scientist, he is associated with research related to water, waste, water fecal sludge management, composting, solid waste management, and food drug safety, etc. He is author of many environmental studies of TSC. He was invited as a speaker in many conferences. Recently, he was invited in IWA, international conference held in Rwanda, Africa. He is a certified trainer and reviewer of many laboratory protocol stand testing. He has handled more than 500 studies and has trained many bioscientists. Prior to CSE, he has been associated with many reputed pharmaceutical industries, R&D, and consulting organizations. He holds a master's degree in instrumentation and chemical analysis, along with many other certifications. He has trained 300 plus biopharma and clinical research professionals, including uh, 200 plus bioanalytical and GLP professionals, 50 plus clinical researchers, GCP inspectors and regulators, 50 plus QA professionals of India, successfully LED 20 plus internationally regulatory inspections, USFDA 5, WHO 5, ANVISA 2, MHRA 2, BCGI 6, and 300 plus clients as auditor successfully conducted and concluded 200 plus audits, monitoring review, USFDA 100 plus, EU 50 plus, WHO 50 plus. Dr. Arvind has acquired his master's in analytical instrumentation and chemical analysis from Jivaji University, MP, India, 2005. During his 18 plus years of research work, Arvind has worked for so many reputed pharmaceuticals R&D. He was the key player in setting up and running a few extremely successful laboratory, Veda CR, Ahmedabad, Sigma, a laboratory Mumbai, and also executed the first HPLC, MS and MS experiment of bioanalytical lab for Sigma lab. So here I welcome you, sir. So before going to the start the session again, I'm just two points for all the participants. See, after the end of the session, you have a queries time. So before that, please don't raise the hand. Is the humble request. Whatever you have the questions, please raise it on the chat box. Chat box will be open by end of the session. So after the end of the session, the speaker will clarify your all doubts. Okay. Okay, sir. You can share the screen now.
So before going to start the topic, actually, first we have to I want to some point out regarding the what is the sustainable urban drainage system. So that is nothing actually. That this is the some engineering things, some related to the management of the your water management in urban areas. So what is the sustainable drainage system? This question is arising in our thinking, John. What is the urban drainage system? So that urban drainage system that provides an alternative to the direct channeling of surface water through network of pipes and sewer to the nearby water courses. So totally, this is the management of water, water which is coming through the natural sources like a rain, which is water which coming through the human-made things like from our household. So if we are enough capable to manage these two sources where water is generated, then that is called the urban drainage system. And sustainability is the question where we can give the solution which is a long lasting and even also in a sense of the finance also, if it is a suitable, that is a sustainability of that urban drainage system. So a urban drainage system is a network of natural and engineered system designed to manage rainwater and surface water runoff in urban areas, so that aim to reduce the amount of storm water entering sewer system, mitigate flood risk, and improve water quality. So if we are talking about the water quality, in that sense, there is a quality of water which is, if we are not maintaining that, that may contaminate our groundwater which we are using for our drinking purposes. So this is only related to the quality of that water. So that also including green roofs, permeable pavements, soils, and the wetlands. So if water is coming, we can manage from these sources, and we can utilize that water to our recharge our groundwater, uh, including like green roof and the permeable pavements and the wetlands. Now, next slide. So sustainable urban drainage system are nature-based solution for managing stormwater. Why we are saying that nature-based? Because there is some surface is having some slope, some curvaceous thing that will make that water to flow towards where is that will go in a sense of the nature-based system. And second one is the engineering-based system. That is, we will make our urban areas to how to manage that water. That is our human made system. So they aim to control water quantity, enhance water quality, and support biodiversity. So what is the importance of that sustainable or SUDS? Actually address urban flooding, enhance groundwater in a sense that if we are recharging that groundwater, right, and recharge and reduce the pollution. So we are also actually responsible to during the we made the drainage system, so there are some actually barriers should be there to we will reduce the pollution also. So objective of this is what is sustainable approach to water management in urban areas. So that management totally is coming through the infrastructure, through the actually our planning of that urban management. So these two things will impact to how to we will made a effective drainage system inside the particular urban areas. So urbanization has led to increase impermeable surface, resulting in water losing and pollution. So this is again actually, if the nature-based system is like that, so we have to give some our effort also. We will make the system like that. The water losing should not be there, because the water losing almost time is making the pollution. If the water is stored or will retain in a long duration, that pollution may occur actually there. So traditional drainage system are overwhelmed, causing frequent flooding also. So SUDS offer a sustainable and eco-friendly approach to urban water management. So eco-friendly is mean that we have to support the system. Ki pollution will be not there. The system we will design like that environment will not pollute it, or environmental condition will not affect it, right? So that type system we have to approach. So now needs for the sustainable urban drainage system. So before that, we have to assess the challenges in urban drainage. So increased surface runoff, roads and building prevent roads and building prevent water from naturally seeping into the ground. So nowadays actually the new urban planning is coming. Their CPHE already taken the actually the things there that type of challenge will not come. But if we are seeing inside the old drainage system, there are so many issues is there, like the clogging. Actually clogging is the very huge challenges nowadays. For example, in Mumbai, actually I'm taking the example from Mumbai. In the rainy season, the whole Mumbai actually is struggling for the clogging system only, because that sewer system is not particular and not having that capacity to load, taking the load of that much of the runoff. So that is related to the flooding. So flooding issue, heavy rainfall leads to urban flooding. Groundwater depletion, insufficient recharge lead to lower water tables. For us, the Bangalore is a major example for that. And water pollution, contamination from roads and industries enter water bodies. Yeah, that is a major thing. So if we are seeing taking the example of this water pollution, so the Ankleshwar is a major example for that. right? So in Ankleshwar during that rainy days, that much water pollution you can see there. The pollution from industries is coming on road, right, and making the flood also. So how should help in these actually? So controls runoff allow water to infiltrate naturally, reduce flooding, so stores and slowly release excess water. So for that we have to some water lodging system also from there, to be during the designing of that urban planning, we have to decide some water storage areas actually should be there. Improve water quality, so remove pollutants before reaching rivers. So this is the major thing actually. If we are thinking, okay, we have to remove the pollutants from that water before reaching the rivers, that is needed. Huge money involvement is there. So sustainability in under the question mark, right? So for that, we have to design our system like that, that naturally water should be treated before reaching the rivers. So for that, only one thing is there, to infiltrate that water or that contaminant should be removed naturally. Why plantation only? And next thing is the support biodiversity. So create habitat for flora and fauna, right? So next slide. Principle of shifts. So mimicking natural water cycle, enhancing infiltration and the evaporation. So that the natural water cycle that will also treat the water, and the pollution control, filtering and treating runoff water, and through nature based through the nature based system. Flood risk management, reducing peak flow through storage and slow release. Biodiversity, so creating green space and habitats, providing multifunctional space like that, integrating drainage with urban planning in a sense that assess the risk also. So next slide is that the key components of SUD, it's a permeable pavement, so especially designed surface that allow rainwater to seep into the ground, reduce runoff and recharge groundwater. So I think so, because I'm not hardcore from the engineering side, but I'm thinking if if we design the our surface like that, the urban surface, and like that their concrete use is, if we minimize the nature based filtration to recharge the ground water will be there, and the reduced runoff and recharge groundwater is the major thing in the permeable empowerments. So that is a natural thing. Their water is reaching to the groundwater in the condition that can sustainable and free from any contamination. And the second one is the green roof. So vegetation covered rooftops that absorb rainfall, right? And lowering building temperature and improve air quality also. Swells and channels. So shallows and vegetated dishes that direct storm water helps filter pollutants before reaching water bodies. That, as earlier slides I also said, there is some plantation is we needed to be, if we want to treat that storm water or rainy water before reaching to the water bodies. Retention and detention basins. So ponds or tanks that temporarily store excess storm water, prevent sudden surge in the rivers and the drains. Okay, so that is also is important thing. Constructed wetlands, so man-made ecosystem that naturally treat wastewater, supports plants and animal life while purifying water. So wetland is a thing there we can take off pollutants, micropollutants from the wastewater to the wetlands and some on the plantation also. Okay, next one. So benefit of SUDS. So economic benefit, lowering the cost for flood damage repairs, reduce needs for expensive water treatment plants. So if we are planning for a urban the drainage system in a way, the water treatment plant cost is reduced, and we have to no need to just implant a water treatment plant for that. Increase property values in green areas, climate resilience also. So help cities adapt to extreme weather events, reduce pressure on existing drainage infrastructure. So these all point, if we are thinking in the way, so Delhi is the prominent area where we can utilize or we can implement these thing to we have for a betterment of a Delhi, even air health, even in a water health. So Delhi nowadays is struggling for these points. Case studies. So London, UK, green roof and the rain gardens. So if in India also, if every building, new constructed building, it's if planning in a such a way, then definitely there will be a very positive impact will be there. And the Bangalore, India, rainwater harvesting and permeable roads. And in Singapore, the water ABC water program, that is citywide approach, integrating drainage with parks and lakes, transform storm water drains into vibrant community spaces. So challenge in implementing the sustainable urban drainage system is a high initial cost. So green infrastructure requires upfront investment, because every green areas, not is the only urban drainage system, but if we are thinking the every green actually infrastructure or required that upfront investment. So we can plan during the planning of any urban areas. There are two responsible bodies is there. One is the CPHETO, that is going to finalize the plan of that particular urban area. Second one, that person or that firm actually, those designing that high rise building actually. So they will also have to take some that type of the decision to giving a green infrastructure view for that particular urban areas. Maintenance requirements. So permeable pavements and wetlands needs periodic upkeep, right? So maintenance is the major thing. Lack of awareness and the technical expertise. Engineers and planners need proper training on SUD design. Yeah, that is actually the things or factor which is that is the culprit behind of the improper design, right? So urban planning constraints. So limited space in highly developed cities. Policy and regulatory challenges, need for better government policies supporting SUDS adoption, right? Now, strategy for successful implementation: integrated urban planning, collaboration between architects, engineers, and policymakers, public awareness and participation, educating citizens about water conservation and SUDS benefit. So because if public aware, then definitely the system will need minimum requirement for the maintenance. The next one is the financial incentive. So encouraging private sector investment through tax benefits, strongly policy framework, enforcing sustainable drainage regulations in urban planning, capacity building and research. So investing in training programs and technological innovation. Now conclusion. So key takeaways: SUDS offer a sustainability way to manage urban stormwater, provide environmental, social, and economic benefits, requires government support and public participation for successful implementation. Call to action: encourage adoption of SUDS in urban projects, advocate for policies that integrate sustainable drainage system, promote community-driven initiative for better water management. So thank you. Now this is time for I'm ready to take the question. I hope it's okay from my end.
Sir, the sessions will till up to 7:30, sir. So If you
So
have
we,
any,
so whenever we can discuss. If the time is a constraint for you, we have to stick on up to the 7:30.
yeah,
So
yeah,
we can take the point and we can discuss, because the the things which I covered, actually that's
yeah.
a brief only. Yeah, right. So I don't know. I don't think that is a short discussion over the slides, but we
Okay, sir.
can discuss over the our discussion point.
Okay, I have opened the chat box. Participants, you can ask the questions now. So, sir will clarify your all doubts. So, meanwhile, I'm helping you out through the questions. So, chat box is open. You can ask questions. So, briefly, sir will going to explain you regarding sustainable in urban drainage system. So, chat box is open. Please you ask your queries now.
Okay, so I want to share something beyond the slide also.
Yeah, yeah, I can share,
So
sir. You can share, right?
yeah. So in my sense, the sustainable urban drainage system is coming from where? That is the question which is coming on our mind. What is the need of sustainable drainage system? Because if we are seeing, or we are going back to see, in a recent past, the some cities is having to fed to manage the drainage system. So, in my sense, if I am seeing the Bangalore, the Mumbai, is the major example for me. Their cities is unable to manage that drainage system, even that groundwater issue also with Bangalore. So this is not the question where the public directly influenced or made this challenges, but the CPHHEO is also the responsible, actually. How I'm saying that? Because the total urban planning is the responsibility is not only the public, but it's also coming through the government bodies, because government bodies is with only the will only the responsible to giving the permission to build such a infrastructure over the city, right? So the collaboration with the government sector and the private sector is a equal essential or equal important to make a system that is a sustainable. So again and again, I'm forcing the meaning of sustainability. So sustainability meaning is not that you have to made a very good system. Sustainability meaning is that the system should be long lasting, should be effective, and should be a support to the environment. So that issues is arised because the planning of that particular urban areas was poor. Are you getting? So this is the thing which is I want to share. And next thing, I want the some water quality improvement system also, because if whenever we are talking about the urban drainage system, the quality is the major thing, because that water ultimately is discharged or gone in either in a water body, either in a river, or either we have to recharge our groundwater body. So the treatment or pollution control is always the important point, and always the important point for that. Right. So source control measure. So green roof is a one of the rainwater harvesting, permanent pavements, rain gardens, and a site control measurement: soils, pond, wetland, infiltration basins, right? And the regional control measure, like that larger scale pond and wetland, river restoration. Yeah. So when I'm saying this river restoration, the one thing is coming in my mind. Nowadays, that issue is very hot issue inside the Delhi. That is a Yamuna, actually. So that river restoration we can do through that water management, and that is a very important. Reduce flood risk by managing storm water runoff, right? So that much point, if we are covering during the our urban planning, that always be the important, and always will be the effective. for the management of that particular urban drainage system. Yeah, now please you can ask me. Almost all point I covered during my this session. So if anywhere if I may lagging, please ask me.
Sir, one question arrived here.
Yeah,
So he's asking that Gauri Desai asking, can show some highlights on job opportunities in this particular area of sustainability.
yeah. So I'm going to read the question actually. So I have a question regarding program. Okay. So can you please give me the some detailed idea about the JNNURM program is what? I am sorry, I am unable to find this.
What is
And
the urban drainage system? However, does it differ from traditional drainage system?
yeah, what is a sustainable urban drainage system and how does it differ from traditional? Yeah, I'm saying now there is two types of the drainage source of drainage. One is the natural drainage that is coming from the rain. Second one is the man-made drainage system, that is a sewer line that is coming from the household. So traditional drainage system, that is channelizing our daily use household drainage through the pipelines and other things, right? And the sustainable urban drainage system meaning is that drainage system is having the enough capable to take the load of the natural source water, that is rain, and second one is coming from the household. So that is a sustainability actually. If we are thinking only traditional drainage system, that is coming household, that is going through the channel thing like in a pipeline, in a some STP sewerage treatment plant, or either in a water bodies, that is a traditional. If that particular system is not enough capable to take the load of the rain water, right? So that never will be sustainable. So that is a basic difference between them. I hope you got that.
As our next question is, what are the challenges of implementing sustainable urban drainage system?
Yeah. So bigger challenge is that the collaboration nowadays is very poor between the private and the government authority, because every policy which is coming in that areas is directed from the government body only, right? If the proper collaboration will be there, the system implementation will be very easy, right? First thing. Second thing is that the training is very poor actually. The engineer, the particular policy maker, if the proper trend and having the enough skills to assess the planning of that urban areas, assessment if the strong, definitely it will be made a plan that will be sustainable. Yeah, next one.
Yes, sir. Next question is, how do SUDs help manage urban stormwater, sir? One of the question from the group members. He
1
just
minute.
pinged out me.
Jawaharlal Nehru National Urban Renewal Mission developed in 2007. So, Sunita Sarangi, you are asking me that is 1 minute, please. I have question regarding this program. So, what is the question actually in this? I'm not getting Sunita Sarangi. What your question actually exactly?
Ma'am, you can elaborate your question in the chat box so that speaker can able to understand the question. Sunita Sarangi.
Yeah, Jalal, which question you are addressing actually? I am not getting here.
How? No, sir. They pinged me here to my number. How do
Okay.
SUDs help manage urban stormwater?
Which thing help to manage stormwater, urban stormwater?
Yeah, urban stormwater.
Yeah, so urban storm water, if we are any type of the water which is coming through the natural sources, like storm water definitely is coming, storm definitely will come if the nature waste source is giving the high amount of the water. So that sustainable urban urban drainage system will help you regarding that actually, right? So there is no second question actually in the mind. The urban sustainability, in a sense, if we are planning or designing our urban drainage system in that way, that is able to take the load which is coming from the either nature-based sources or our man-made sources actually.
Okay, sir. Amendra Mishra, you are raising hand. You can post your queries in chat box so that we can go for your questions. Amendra Mishra. Sir, one question arrives again. Anil Kumar, sir, how do sustainable drainage system helps manage stormwater runoff? So just now I think you have clarified.
Yeah, so runoff actually major thing.
Runoff, yeah, runoff.
Yeah, yeah. So manage stormwater runoff. So Mr. Anil Kumar, actually, if we are planning a sustainable drainage system, again and again, if we are putting the sustainability thing in a drainage system, then definitely there some solution will be there to manage the stormwater runoff. So like that, I am saying you, the green roof, right? Green roof is a one thing. Second thing, if the water recharge is there, that is a second thing. If the pipeline, if the pipeline of your city is enough capable, then you can direct that storm water to a particular water body, right? So, and the clogging, I gave you one example. For the Mumbai, there is a clogging is the major thing. That polythene, that garbage is made the clog the system. That's why that's runoff is arises. So if we are managing that garbage in a proper way and we are avoiding the clogging, the your system will be sustainable and we can manage that thing. Thank you. Yeah, please.
So next one is from Dr. K. Muhammad Imdadullah Khan. How do SUDS help reduce flood risk? Regarding flood risk is asking.
How do suits help manage urban storm water? I am not getting that question.
Flood risk, sir. Yeah, floods. During the flood situation, risk management is there now. So I think is asking like that.
That question I am not getting here, Jalal.
It's in field one, sir. I'm telling you the question. How do
Okay.
SUDS help reduce flood risk?
Flood risk.
Yeah.
So flood risk is in a sense if the water losing happening, if the water running is beyond the limit, right? So that only will make the flood thing. But if flood is never expecting, if the system is uh, made by proper assessment, if we are assessing the risk also during making that system, so definitely that proper means whole urban that city, particular cities, that sewerage water, that runoff water is going in a proper channel and going to a some means water lodging or some water bodies, then definitely we can avoid that flooding thing. But we can't avoid the situation if water means running is very high, then we can't avoid that thing or that scenario. I hope you are getting my thing actually.
Yeah, sir. Yeah. That's nice, sir. So again, one question is that from they are pin downing me, sir, as
Yeah,
a coordinator. That's why I will tell the questions so that it is easy for you to clarify. Okay.
yeah.
So, what is the primary goal of a sustainable urban drainage system? Asking, sir. From this question is
Mhm.
from MD Akram.
Okay. So, Mr. Akram, actually, the goal is that we want to our cities is clean, free from water losing, free from any water contamination in either in a sense of the groundwater or in our surface water. In a surface water, again, is a two things. One is a pond, second one is the river. So ultimately, if the system is not proper, then definitely that system will affect our goal. So goal is that we want if rainy high even high rainy season is there, raining is there, that rain will be manageable, that rain will not affect our daily life, right? So that is goal only actually.
Okay, sir. I think the question has clarified. So again, one more question arrives, sir, here in chat box only. Nagaraju Chilaka. Good evening, sir. My question is, what are the current best approaches known and in use for computing the peak stormwater flow rates in urban drainage systems?
Yeah, this is the question related to the calculation. So I think so. I am not right person to give the exact answer, but I have to guide you. So this is the some waterboard related question actually. Yeah, the computing the peak stormwater flow rates and drainage system. So you can go through some actually Indian water board. You can definitely will find out your answer over there. Actually.
Yeah, I think we can follow for the water management system journals as well for that.
So if you are even if you give me time, so I will be give the answer of this question over the mail to
you can have the answer. You have
yeah,
half an hour,
yeah,
you can, yeah,
yeah.
you will wait, no problem. Before that, again, one question arrives sir here
Yeah.
from Sai Kumar. How do SUDs promote biodiversity in urban areas?
Yeah, this is the question. I am actually waiting on this question.
Yeah.
So actually, in a from the afternoon, I am thinking over this question actually, how this should promote biodiversity. Right?
Yes.
So biodiversity meaning is what? Biodiversity is the whole environment is coming in the biodiversity. And what is the environment? So every living organism which is exposed to each other, that is a environment actually, right? So every living organism, if are sustainable and every living organism having the enough space to living and having the enough sources to living. Sources is what? So for drinking, that there is if there is a water, for the food there is a should be food, food should be there, and habitat. So three things is required for a if we want to measure biodiversity. So three things we have to design for every living organism. So that sustainable drainage system is not only the sustaining the water only, but if you are managing a sustainable drainage system, that is also help to affect the every creatures on the earth actually in your areas also, right? So on that sense, that drainage system is supporting to the biodiversity.
Yes, sir. So next question from Dr. Farid, sir. How can green roofs contribute to sustainable drainage?
Yeah. So green roof in a that way ki, that runoff, we have to we can reduce the runoff of that water through that green roof actually, right? So that if we are making some green roof in our particular building, so the runoff coming through the rainwater, we can reduce actually, and that way only that participating that runoff sorry, a green roof is participating very small part, but that is it, that is there actually for sustainability.
Sir, sir, kindly switch on your video screen.
I can switch my video, but thing is that the network band is very slow.
Okay,
So
okay, sir.
voice will break. That's why.
Oh, sir, please carry on, please.
Yeah.
Sir, next question is from Dr. K. Muhammad Imdadullah Khan. How do SUDs improve water quality?
Water quality. How do you suits?
No,
Suits never improve the water quality, but we have to design our suits like that. We have to improve the water quality, right? Automatically, suits never will improve the water quality. But if we are designing our suits like that, our goal, if that is that water we have to treat before discharge or before meeting or before reaching to the water body or even groundwater. Before that, we have to treat in a that way. So I can say that water quality thing is the most important part in every suits planning. So we have to plan that actually. So during how to improve. So improvement is thing like that. There is two types of the contamination is there. One is the biological contamination. Second one is the chemical contamination in every water. So chemical contamination we can reduce through that contaminants can absorb by the plants. So if plantation or vegetation is there, the micronutrients absorbed by that particular plant. And the biological removal. So only two things is there that can reduce that biological contaminants. One is the oxygen, second one is the sunlight. So if water, that particular water, if exposing to air and exposing to the sunlight, at biological contamination we can reduce. So in a that way we can reduce the contamination or pollutants from the water.
Okay, sir. The next question is from Anil Kumar, sir. How can sustainable drainage be used to improve water quality in urban areas?
Yeah. So earlier I also addressed these question only. So the water quality means what? Water quality means that we have to avoid the pollutants in water, mixed water. If mixed, then we have to treat, right? So we can't avoid actually to that storm water, that rainy water cannot meet to the pollutants, but we can plan that system in a such a way that water should exposed to the nature based system, their pollutants or contaminants may reduce actually, right? So there is two types of the contamination is there, as earlier I said actually, chemical and biological. So chemical you can infiltrate through the vegetation or plantation, and for the biological you have to depends on the sunlight and the oxygen actually.
Yes, sir. Thank you. Again, the next question is from Dr. Ranjan Kumar Behra. How do you see robotics and Industry 4.0 in suits? What could possibly be the scope of new age technologies in suits? I mean, sustainable urban drainage system.
Yeah, how do you see robotics and Industry 4.0 in suits? What could possible be the scope of the new age technology in suits? Sir, I want to take some time to address this question. So definitely I will address, but I will address over the mail. So give me some time.
Okay, sir. So next question is from HOD of Civil, I think from college. What is the difference between SUDS and traditional drainage?
So, sir, actually earlier I addressed this question. Actually, I have to again also. So, sustainable drainage system and the traditional drainage, in my sense, is that traditional means that we have to managing the sewerage system actually. So, sewerage system, traditional sewerage system means is that water is coming, or that discharge is coming through the household, and a whole city is managing that household drainage is called the traditional drainage system. When that system is meeting to the rainwater, right? So that is a natural sources of that water. So if the system is enough capable to take the load of the household drainage and the rainy drainage, that is sustainable drainage system.
Okay, sir. So next question they have pinned me. So is Mr. Noman, what is the role of vegetation in suits in sustainable urban drainage?
Yeah.
It's a nice question actually.
Yeah. So I am giving you the answer. This is a very nice question. So vegetation is improving the water quality, right? First thing, and the second thing is that the vegetation will improve the soil quality also if the suits are planted, right? So in my sense, there is two things there. So vegetation will filtrate your water and will improve the soil quality.
Oh, okay, sir. So next question is, how do suits recharge groundwater?
Yes. So if rainy water is there, and that water quality is not having any issue, so the natural recharge is there. If we are taking that runoff water in a some source of some nature-based logic system, right? So that system will absorb that water up to the groundwater, and that water may be percolate or will percolate up to the groundwater. That is a natural recharge system.
Okay, sir. Sir, next question is from Reshma Sultana. How do suits protect rivers?
Yeah, river. So suits. If we are, if I take took the example from Delhi, Yamuna. So if Delhi is planned like that, if or government is thinking, ki they want to means revive the Yamuna. If suits planning like that, ki the run of water if going in a Yamuna that way, then first thing is what will that pollutants which is already is there in Yamuna, that will be diluted. The level of water will be increased, right? So if the level of water will increase, then definitely there will be chance to the improve that water quality of Yamuna, and there may be some also the scope of that treatment system also. So that thing in my sense is there.
Okay, sir. So the next question is from Mr. G. Srikant. How do suits reduce pollutants?
Yeah, suits never will reduce the pollutants, and this is the second time I'm addressing the same thing here. So we have to design the suits like that way that contaminated water and or pollutant before meeting that water to some water body, some river, we have to remove that pollutant, right? So itself suits will never remove, but we have to add some components in suits, or we have to design our suits like that. If before reaching to the some water body or river, that will be or that should be removed from there. So what is the scope or what is the factor of there? So the factor is that our water body or our that suits water passing through some vegetation, some plantation areas, right? Like wetlands or some plantation should be there. Before reaching that, the water should expose to that, and water should expose to the sunlight and air also. So there may be chance to improve the water quality. And the second thing is that one more thing I want to add in that question. So if the enough area is there, then we can also made our water that suits water to percolate inside the groundwater. So that is a natural infiltration that is going on there. So on that way also we can treat or remove the contamination from the water.
Okay, sir. So someone said that very interesting session. Thank you for this. Yeah, it was interesting session. Thank you. So next question is, sir, how does the type of file affect suits?
Sorry, sir.
How does the type of file affect the suits? He mentioned here, sir. I
I'm
think,
not getting the question actually.
yeah. Sir, Anil Kumar, sir, you can clarify your question here so that we can understand the question first. How does the type of soil affect the SUDS is asking?
How does the type of soil affect the suits? Soil. Soil affect the suits. So definitely soil role will be there in our source. So Anil Kumar, please give me the time, and Jalal, I am requesting you
Okay.
which question I am taking to address later. Please
Yeah,
note down that and please mail to me. So
Okay. I'm
within
not
one
doing
or
sir.
2 days, I will give you the answer of that. So Anil Kumar, I am taking this question for the later, right? I will later address to later on. So thank
Okay.
you. The question is very important and good question only. Thank you.
Okay. So next question is, how do suits integrate with urban planning?
Yeah, so how do suits integrate the urban planning? So Jalal, this question also you have to take for the later on,
Okay, sir, I
right?
will take down.
I want to go through some literature after that I will say, because I don't want to give the any answer which is not complete.
Yeah. How so next question is, how do wetlands act in suits?
Wetlands act in a suits, right?
Yeah.
So wetlands first thing is the storage thing. So the scope of the wetlands to we can store our that storm water, that rainy water. We can use that wetlands to recharge our ground also. We can also take that wetlands to treat our water also. So in my sense, there are three goals, three scope under the wetland. One is the treatment, second one is the recharge, and third one for the storage.
Okay. What is the source control in SUDS, sir? Next question.
What is the source?
Control in sustained urban drainage system.
What is the role of 1 minute?
Source. What is the source control?
Source control in a
SUDS, sir. What is the source control? He's asking.
source control and a source. So I am giving the answer, but if that is not as per your expectation, please revert me. So in my sense, source of that water from the natural sources. Second one is the house sources. So control is that we have to minimizing the unnecessary use of water inside the household. Second thing is that we have to assist a proper designing on the basis of that particular area, how much raining capacity of rain is there. Accordingly, we can decide the control measure, how to control or how to make the system that enough capable to take the load.
Okay. Sir, next question is, how does permeable payments act in SUDS?
Yeah, so permeable payments is nothing but we can use that permeable payments for the recharge of our groundwater. And the thing is that if the designing of that suits like that, then there is a porous pavement is there. That porous pavement is what will do or act, that will infiltrate our water, the storm water, and take that water up to the ground. So infiltration will be there, filtration will be there. So definitely that pavement is the important thing to manage the storm water, right? So or reducing the runoff.
Okay, sir. Thank you. And next question is from here in chat box only, sir. From Sunita Sarangi. Sir, I have a question. What are the property of concrete we should look at while designing the SUDS, and as it could get affected by different kind of chemicals, fungals, and some toxicity of water flowing in it?
Okay, so in my sense, concrete is a totally actually neutral things for the biological, like you are saying fungal here. So biological things is never affect that, but there is some corrosion may be there, right? And for the chemical thing or chemical contaminants, definitely concrete will dissolve with if water is highly acidic or having the quality of basicity. So chemical contaminants may affect the concrete, but biological not more than that, right? So water toxicity definitely will increase in the sense of that chemical some in a longer use or longer exposure. So that chemical may deposit it inside the concrete. If the water is exposed that concrete, the water may be contaminated or having toxicity.
Okay, sir. I hope so. It's clarified. The next question is, how do rain gardens contribute to sustainable drainage system?
How to rain water?
Rain gardens.
Rain garden. So I want to see this question actually. Definitely, rain garden is what are the related amount of I am not getting the question. Give me a minute. Give me a moment.
Yeah, okay, sir. So I'm repeating again, sir. How do rain gardens contribute to sustainable drainage system?
Yeah. So in my sense, rain garden is the thing is that there is some enough space is there to storing the rainwater, to having the enough vegetation is there to infiltrate the water up to the ground, right? So definitely that rain garden will help in a SUDS actually. So a rain garden is a good idea actually for restoring the groundwater and giving the enough resources to our vegetation, even our biodiversity, for improving that.
Okay, thank you, sir. Sir, one question from Dr. Mehboob Pira K here in chat box only. So he's asking that what are the related important topics in this area for doing PhD for the students?
Yeah. So that is a good thing actually. So in a PhD thing, my concern is always there. We always choose the topic which is applicable, which is having the capacity or having the actually potential. We can implement that actually. So if you are thinking or in a zone to search some topic, so my suggestion is that choose the topic which is applicable or addressing the current challenges in that particular area, or after the PhD your topic will be implemented or reducing the some problem for the community.
Okay, sir. Sir, next question is how does infiltration helps in suits?
Infiltration. So
Yeah.
infiltration in a two ways. If enough infiltration is there, so first thing is that infiltration definitely will improve the water quality, and infiltration will definitely will improve the groundwater level also.
Okay, sir. The next question is what are the economical benefits of suits?
Economical benefit, for the economical identification or assessing the economical benefits, so I am giving the answer, but I don't think so that's enough. So I will later on also will address this question, but
Yeah,
I'm
sure.
trying, I'm trying here. So economical benefit in a that way, okay, we are reducing the cost to treating the wastewater, because during that rainy season huge water is generated. If the suits is proper and suits are planned proper, that rainy water we can manage in a very good sense. So we are reducing the cost of that wastewater treatment. Then definitely if the proper source is not there, the whole city life will disturb, and then definitely then some economical burden will come out arise there. So if source is proper, that thing will not happen.
Okay, sir. Next question is how do suits support climate change?
Yeah, so Jalal, please write down this question for later on. I will
Yeah,
address it
okay.
because that question is not having very want some
Yeah, okay, sir.
assessment also.
Note
Right?
down. Yeah, I will note
Yeah,
down.
yeah,
What are the some next question, sir? What are the challenges in implementing suits?
yeah. So challenge is there. I addressed actually in my slide. So one
Yeah,
thing is that proper collaboration nowadays is not there between the private and the government sector, right? So and
yeah,
the capacity building in a sense of the training. The person who is involving in planning of infrastructure of the urban areas, that should be proper trained, and having the enough knowledge how to make the suits, that proper for a proper management of that nature based and man-made actually discharge water.
okay, sir. So next question is can suits help prevent waterlogging?
Yes, definitely. Whole scenario, goal is that only, na? So what is
Yeah,
the suits? In earlier slide, I told you the suits is that we have to manage our city like that. There, our daily life will not affected. Why any water lodging actually, right? If rainy water is there, if our our household water is there, that water lodging should not be there actually. That is a source.
yeah, okay, sir. Sir, just a minute. I'm asking to participants. So the session will end at more 10 minutes. So before ending the session, if you have any queries still, you can ask in the chat box. So before going to that, sir, another question is how do suits contribute to ecosystem?
Yes, ecosystem. So please note down this question also, Jalal. I want to
Yeah,
give a
okay.
very elaborated answer of this question.
Okay, sir. Another question is, how can suits be used in parking slots?
Parking slot.
Yeah.
So in a parking lot, actually, there is enough space, but I don't think so that we can use that particular area under the suits actually. Suits only help the parking area should be clean, should be avoided by the water lodging only. That my sense, that should be there.
Okay, sir. Sir, next question is, what is the role of check dams in suits?
Yeah, check dam. Yeah, check dam. We can use the check dam under suits as a water storage system actually, right? In case there is a no water body, there is a no river, then where we can discharge that channelized water actually. So that check dam we can use in a storage system of that suits.
Okay, sir. The next question is, can suits used in coastal areas?
Yeah, you can use anywhere actually. Suits is not related to the water body. Suits related to the city actually. If the near to the coastal area, there is a urban population is there. If urban infrastructure is there, you can implement anywhere. If urban population is there, if you are planning to make some urban designing is there, you can implement your suits over there. And that is essential actually. Even in coastal area, that is a high demand thing actually.
Okay. The next question is, how do permeable surfaces reduce runoff velocity?
So take this question actually. I will give the elaborated answer of this.
Okay, sir. I will note down. So, next question is, what role do local governments play for adoption purpose in suits?
Yeah, actually, government only will make the policy. Government only will give the relaxation in the taxes, right? Government only will help in an economic thing or in a financial thing to make the suits actually or design the suits, right? And the collaboration is very important between the government and the local body. So definitely, government always will play a major role in the designing of the suits because the in a individual can't made a suits actually, na? So government is a major will play a major role.
Okay. The next question is, how do suits contribute to sustainable development?
Yeah, this is not a question is very big and answer should be very big. So please note down.
Yeah.
I will give elaborated.
Okay, sir. Sir, before that, again, I'm reminding the participants, still 8 minutes is there for your queries. So after that, the second session will be going to start. Before that, if you have any questions, please uh, post your questions in chat box. So the next question is, how can suits prevent groundwater contamination?
Yeah. So suits in a suits always some factor is there that will make that water treated and removal of the contamination by natural things. So natural things is always is there. That is a sunlight, air, that is a plantation, that is a vegetation, that is a soil. So that natural factor is there. So I'm again repeating: soil, vegetation, plantation, air, and sunlight. That is the natural sources of the treatment. So if any suits, we are taking the role of these five things, then definitely that water will be treated from there.
Okay, sir. Sir, thank you. I think the questions kindly request any model. So last question, sir. I think so. So before going to end the session, sir, I would like to congratulate all the participants. Even it's a festival, so the participants in a huge number. And thank you for your
Yes.
session as well, sir. So before going to the second session, so our coordinator will have some points to discuss here. So we will discuss some points, sir, and thank you for your session, sir. I have noted
Thank
down
you.
your questions. and I will
Yeah,
mail you, sir.
yeah, thank you.
Yeah,
So again, thank you to all and happy Holi.
thank you very much, sir,
Is
coordinator,
there
sir.
any feedback
So,
from section? Yes, this section feedback will be shared shortly, and next section feedback will be sent shortly. That test will be conducted by the Google form. Will be shared the ATAL portal. No, the Google form will be given by us only. It is not ATAL portal. After this evaluating this test, we will submit this marks to ATAL. After that, you have to fill the feedback form to in your portal, participant portal. Okay, we will give this some ID to you. Please go through it. We will share this ID, attendance ID. Based on this ID, you have to first enter your ID. Next, you have to enter your details which you mentioned, your participant registration, then email ID, then designation, then college detail that is required. Yeah, ATAL portal assessment. No, assessment for Google form only. It is shared by us only. Okay, thank you, thank you, thank you.
I hope all participants have. No, before going to start the session, once again, I'm repeating that these all FDP sessions, or total 13 sessions are there for 6 days. It will be calculated according to your attendance of 80%. Then only the certificate will be generated from ATAL. So there will be test tomorrow after the end of the sessions. But again, our coordinator sir has noted the points as well to you guys. So note down that points. The sessions tomorrow will start from 2 o'clock afternoon. Then before going to start the session, I would like to call our next speaker, Dr. Sri Kalyana Ram sir. Sir, am I audible to you?
Yes, sir. You're
Yes,
audible.
sir. Yeah, okay. Hello, guys. We will start the sessions now. So, sir, before going to the start the session, I would like to introduce your introduction part. And once again, I'm repeating to the all participants. After the sessions only, the questions will be you can post in the chat box so that our speaker can clarify the questions after the end of the sessions only. Okay. So now I would like to call our next speaker, Dr. Sri Kalyana Rama Jyosyula. Is currently working as an associate professor, Department of Civil Engineering in Mahindra University and co-lead for Smart and Sustainable Materials Lab. He is also a funding director of Precast Client Confirm Private Limited, Astad Atal Incubation Center for Mahindra University. He completed his PhD from BITS Pilani Hyderabad campus, MTech and BTech from VR Siddhartha Engineering College, Vijayawada. Prior to joining Mahindra University, Dr. Kalyan Garu worked for BITS Pilani Hyderabad campus, VR Siddhartha Engineering College as assistant professor. He had also worked as a R&D cell coordinator and associate professor, Department of Civil Engineering in VBIT Hyderabad. Dr. Kalyan's research interests include developing low-cost precast wall panels, rheology of ultra-high-performance concrete, and 3D printed concrete, and risk assessment of construction projects, repair and rehabilitation of concrete structures. Dr. Kalyan is a young member of the International Union of Laboratories and Experts in Construction Materials, Systems and Structures, RILEM, and a technical committee member representing India for early age cracking of concrete and alkali activated concrete for RILEM. Dr. Kalyan is also a life member of the Indian Concrete Institute and Indian Association of Bridge Engineers. Dr. Kalyan is a Level 1 Certified Institute of Risk Management professional from UK, United Kingdom. Dr. Kalyan is also a technical committee member of Bureau of Indian Standards on Risk Management and Building Information Modeling. Bentley distinguished educator and is also a construction life cycle assessment specialist from One Click LCA. Dr. Kalyan had received a Young Researcher Award for the year 2022 by STEM Research Society, so it's recently only, and received an International Young Researcher Travel Grant from the International Association of Fracture Mechanics of Concrete Structure for attending a conference in France. Dr. Kalyan delivered more than 100 invited lectures across the country at various state and central level, academic and industrial organizations, and delivered keynote and invited talks at various international conferences on sustainability, risk management, and building information system, BIM, finite element modeling, and earthquake resistance construction. Dr. Kalyan has guided one PhD student, is currently guiding 4 PhD students, as supervisor and 6 students as co-supervisor. In addition to working with a postdoctoral fellow, he has 22 papers in international journals indexed in Web of Science and Scopus, 10 book chapters, 30 papers at various national and international conferences, and 2 articles in a reputed national magazines. He also filed 5 patents applications, of which 3 of them got granted and 2 got published. Dr. Kalyan is handling 4 industrial research projects, 5 industrial consultancy projects, and completed 1 government-funded project, co-investigation from DRDO, total of worth of around 90 lakhs. He is a quality consultant for many industries across the country. He is associated with the various collaborators from India, Germany, UAE, that is Dubai, UK, Portugal, France, Australia, and Chile. Through participation in this faculty development program, Dr. Kalyan aims to provide insights on sustainable living as a civil engineer, predominantly focusing on materials design aspect and how the draft code of IS 456 emphasize sustainability, providing valuable insights and practical guidance to the participants. So, before going to start the session, again I would like to call Mr. Dr. Sri Kalyana Rama sir. Sir, it's my honor to introduce you and sharing the screen with you, sir. So now I am handovering the session to you, sir. You can continue the session now.
Okay. Thank you so much, Jalaluddin sir. We have been in touch with each other for quite some time regarding this program. And first of all, congratulations to Department of Civil Engineering, Lords Institute of Engineering and Technology for getting this ATAL FDP granted from AICTE. It is
Thank you very much.
Actually a very good thing, and the topic is a very, very important topic, especially for our country in terms of sustainability. Thanks to head of the department and the organizers of this program for having me as one of the resource persons. So I will share the screen right now. Sir,
yes,
please
sir.
I'll just share in a minute. Yeah.
Okay. While you share the screen, again I'm giving two to 3 points for the participants. Please, participant, the session starts from 7:30. By the end of 8:45, last 15 minutes is for your queries, so that you can post your queries in chat box. So don't disturb the session in between. Please don't raise the hands also. It's a humble request. Sir, you can continue, sir. Sorry for the interruption.
No problem. I'll just share the screen meanwhile. Okay. I hope the screen is visible.
Yeah, it's visible, sir. Okay.
A very good evening to all the participants, and first of all, happy Holi to all of you, and happy Ramadan month. There are a lot of auspicious things happening in and around us. So I also once again thank the Lords Institute of Engineering and Technology, especially organizers. It's a Ramadan month. They are fasting and still they are coping up with such wonderful programs. Congratulations and all the best to all the organizers here. So now coming to today's topic, I'll be largely talking about for the next 60 to 70 odd minutes on sustainability through low carbon materials and how to reduce the embodied carbon or carbon emissions into the atmosphere. So when we are talking about the sustainability part, most of the times we think that, sustainability is something that is associated with materials, and largely there are other factors that are to be involved, but we focus mostly on materials. One of the major challenges that we need to look into at every given point of time is that sustainability is not a term which we generally focus only on the materials part, but it also involves, again, a lot of processes from the birth of a structure to the end of a structure. That's what we call it as cradle to grave analysis. So this particular topic, whatever I'm going to talk right now, would largely focus first on the material part, and then I will talk about the embodied carbon and how to calculate the embodied carbon. And then I will also end the presentation with some of the very good initiatives as an individual which we can take in terms of taking the sustainability as a part of our life as a civil engineer. Just a minute, in order to save the bandwidth, I will just switch off my video. Okay. So now, so to start with, this is where we are right now. The United Nations Sustainable Development Goals, and there are 17 Sustainable Development Goals proposed by United Nations and accepted across the globe. Now, as a civil engineer, it's our responsibility to ensure that we adopt most of the Sustainable Development Goals. That can be clean water and sanitation, affordable and clean energy, industry, innovation and infrastructure, sustainable cities and communities, and then climate action. So these are all some of the closely aligned sustainable development goals for our civil engineering part. And of course, there are other goals which we can definitely include, but again, it requires other departments and other domains to actually work with it. So, as I told you, I'll start with construction material. So, I've seen the list of topics that you have been through for the last 4 or 5 days. I will try to ensure that it's not repetitive, because there are some topics on eco-friendly materials, there are some topics on sustainable materials. I will try my level best to see that it's not overlapping with most of the topics that you have already learned. But yeah, if you get stuck at some point, you please post your question in the chat box. So I'll again try my level best to answer almost all the questions at the end of the talk. If not, you can write to me personally, and I'm more than happy to respond to your emails. So construction industry has seen a drastic change in the recent past, and one such change is natural sand to manufactured sand, because one is the availability. The other most important thing, especially when we talk about sustainability, is the depletion of natural resources. So when we are talking about the depletion of natural resources, natural sand is the topmost criteria. And that's where the society, especially in most of the metropolitan cities or places, actually they try to construct any of the construction or infrastructural sites, they tend to use this manufactured sand. And it can also be a crushed sand as well, or the robo sand in some places they call it as, or crushed rock fines, which is an alternative to natural sand. It's economical, sustainable, and has got very good properties when we are using it in concrete. Strength-wise, you might not say a significant increase, but the other properties like durability, or when it comes to the economy of the overall concrete per meter cube, it will come down when we try to use the alternative sands. So as the topic says, sustainability, I will also give a briefing about what I think most of you are aware that, or all of you are aware that IS 456 now is going to get revised, and the draft version of IS 456 was released in the month of January 2025. And believe me, the draft version of IS 456 is almost about 500 plus pages, and they have given a fantastic guidelines of what tests to be performed, and what are the percentages replacements of each of these materials, which makes our life more easy when we are trying to adopt in terms of construction. So similar to natural sand, even the natural aggregates also are actually being shifted to crushed aggregates because of a lot of waste that is available in and around. And one such example is recycled coarse aggregate, or recycled aggregate, recycled concrete aggregates. So there are different names, and one such company which are producing or manufacturing the recycled aggregates is Ramkey. They have been doing a fantastic job in creating the awareness of different types of aggregates which are available in the market, and yeah, it's working very nicely for them. And in fact, for the society also, when we start replacing the natural aggregates with the recycled aggregates or crushed aggregates, it is giving a lot of benefits, not only in terms of sustainability, but also in terms of the flexibility of the construction as well. So another interesting thing today, when we talk about the recent advancements, if you see the manual mixing of cement and sand, or mixing on a given site, there are a lot of challenges that are involved. Now today, people have come out with ready-made plasters, ready-made mortar, or ready-made concrete. one such interesting thing is ready-made concrete, because concrete is made, is prepared at the RMC plants, and it will be stored in the bags of weight around 10 kg, 15 kg, or 20 kg, or 25 kg maximum, with a very good retention time. That provides a lot of flexibility to overall users across the country. Not only that, the concrete, like cement bag, you can take concrete bag and directly pour it onto the site. It might not be a very good solution for high-rise constructions or mass construction that is happening, but for small-scale construction activities, this is a very good bet, and they are giving retention time up to 3 to 4 hours, which is a very good achievement. On the top of it, we also have the ready-made dry mix. It's a very simple solution. You will get everything mixed in the bag. Whatever mixing happens, that is put into the bag, you will directly take it to the site. They will give the specifications of requirement of water to be added. You just need to add water to the dry mix that is available, and it's done. You are getting a concrete. So these are the kind of shifts that we are trying to look into. And again, clay brick to autoclave aerated concrete blocks. This is again an innovation, and of course, it has been in existence for a quite long time with fantastic mortar joints. And so these AAC blocks are very much popular in the country right now, and almost again, complete construction or infrastructural sector is moving towards AAC block compared to the conventional clay or red bricks. So the old days, we used to talk about 1, 2, 4, or 1, 1.5, 3 for different grades of concrete. But today, with the flexibility that we have got, especially with high strength concrete, the concrete is providing us with necessary strength up to 80 megapascal. Now, when you see the draft code of IS 456, the code is allowing up to a maximum of 100 megapascal or beyond that as well, as long as the right choice of materials were picked. So this is something which is actually too good when we move forward. So for high strength concrete, we can go beyond 100 megapascal also without increase in the cement content, which is a very good achievement today that we can crack. So right now I'm directly coming to the topic, like low carbon materials are the materials which actually reduce the amount of carbon dioxide emission into the atmosphere. So the list that is shown here consists of cement replacement materials as well as aggregate replacement materials. Now, which largely means not every material that I'm showing right now might be practically feasible, but especially when it comes to cement replacement materials, except for rice husk and sugarcane bagasse ash, almost every material used in practice. In fact, the sugarcane bagasse ash and rice husk ash has also got a fantastic potential to be used in construction, but people are exploring multiple ways wherein structurally these materials are feasible, compatible, and would lead to a stable structure at the end of the day after designing it with these materials. Coming to aggregate replacement materials, we have a very limited options, largely associated with construction demolition waste, crushed rock fines, waste foundry sand, coal bottom ash. So these are the popular materials which are actually be used in India right now practically. Granite waste is also a possibility, but it's costly. Otherwise, it's a very good option. So when I'm talking about these cement replacement materials, let me also take you through some of the interesting aspects of blended cements and their status in India, where none of these cements that are used in concrete, they are not new to the market. Actually, people have been using it, and most importantly, you can see that the Portland pozzolana cement, which consists of fly ash, Portland slag cement, up to 65% slag. Portland limestone cement is available, limestone calcined clay cement, or the composite cement, which is a combination of both fly ash and slag. They're all present in the market for quite some time, and because we have got IS codes for each of these things. Even in the year 2023, they have released a code. Bureau of Indian Standards released a code on the limestone calcined clay cement to be used, wherein 50% should be, or equal percentage of OPC should be used. If X by 2 is OPC, remaining X by 2 will be limestone calcined clay. So there are production units now. Ultratech is also starting to manufacture the limestone calcined clay cement, and it is going to be revolutionary, especially for the most parts of the country, most parts of the states in the country. So that is about the blended cements and their status. Now, when we move further, we will see, I have listed some of the interesting materials that are available in the market. And you can see that the different materials, particle shape, particle size, specific gravity, surface area will vary. Particle size plays a very important role, especially when we are targeting the high strength concrete. So largely when you see high strength concrete, it gives us an impression that you have to use more cement, but largely it's not required. Some of the materials like silica fume or marble powder and limestone powder will be more than sufficient to be used by reducing the total quantity of cement. And the reason for that is the particle sizes are low for materials like silica fume, rices, sugarcane bagasse, or GGBS also. So when the particle size reduces, your specific surface area, there is a high tendency that it will increase. And that's what you can see, especially when it comes to silica fume and rices cash. And the specific gravity, of course, for the mixed design plays a very important role. And the shape of the particle of each of the supplementary cementitious material or cement replacement material again defines how much volume or how much densified will the mix be. Densification of the mix is a very important part, especially when you are working on higher grades concretes beyond the M50 grade. You wanted the materials to be used in concrete are densified enough so that they would give nice mix without any voids, and which is looking like a compact kind of a structure, like a cube or a beam or a cylinder, whatever you are casting, and it will give very good strength ultimately. The specific surface area, as I told you, with the increasing specific surface area, the demand for water will increase. So now when the demand for water increases, again we need to balance it with suitable admixtures, especially high range water reducing admixtures, or super plasticizers. So these are some of the important points that we need to keep in mind. Like you pick any supplementary cementitious material, you will still have to work on a suitable balance between the water binder ratio and the super plasticizer dosage. That is very, very important. And that plays a very important role overall in that plays a very important role. So again, when we are talking about surface area, as I told you, it actually increases the demand for water, and as it increases the demand for water, what will happen? Most of us will get a doubt that, okay, what will happen to the strength of concrete? But a material like silica fume, which is actually rich in silica, doesn't react with water. So the whole hydration process has to be taken care by the materials like OPC or any material which is rich in calcium. Any material which is rich in calcium. Like limestone powder is rich in calcium, marble powder is also good at calcium, GGBS has also got close to 35 to 40% of calcium. So these materials would contribute to the hydration part and other aspects. So even if such scenarios occur, the dosages of these materials, when they don't react with water, is very less. So as such, we need not worry about increasing water content would reduce the strength. That's not actually, Abram's law is what that talks about. With the increase in the water cement ratio, strength will come down. But when you go for higher strength concretes, water content has to be less, right? So now you see, So as I was talking about, the specific surface areas and the requirement of water, you can see here for silica fume and rice cash, it is so high because the specific surface area is high. Now, there are two types of reactivities that would happen overall. One is the hydraulic reaction as well as the pozzolanic reaction. Now, when we are talking about low carbon materials, we would largely recommend the materials which have got the pozzolanic reactivity. So what is pozzolanic reactivity? So pozzolanic reactivity means it will not directly react with the CSH gel. It requires an extra secondary source of reaction through CH. So you can see the materials which are actually rich in calcium or materials which consist of calcium are hydraulic in nature because they don't require any secondary reaction for it to form CSH gel. But you see GGBS, limestone powder and marble powder, all the three materials have got some content of calcium present inside, which means it will react with water. That's why it is hydraulic. Pozzolanic requires secondary source. Now workability, because the water demand will increase for both the silica fume and rice cash, you might see a drop down of workability, especially when you are using beyond the required dosages. And heat of hydration, you can see here, now shrinkage again is one of the biggest threat in concrete, especially when we are talking about cracking. Shrinkage cracking is a predominant factor across the concrete, and there are different types of shrinkages and different types of crackings are possible. Now, so you can see there shrinkage where all it can increase and decrease. And then the strength after 28 days, except for silica fume, limestone powder and marble powder, for all other materials, the strength will be less compared to a conventional concrete. Of course, these are the tentative replacement levels, but I have seen GGBS up to 70%, fly ash up to 40, limestone also 40, silica fume maximum 10, don't go beyond that. Rice as cash, if you go beyond 7%, there is a high tendency that the strength will come down. So you can use 20% only when you are trying to develop concretes of higher grades. Lower grades, it's not a big, ideal solution. Sugarcane bagasse also is similar to rice. Marble powder is again up to 10% because it is not economical. Almost every material will enhance the durability of concrete. Now, the IS 456 guidelines, the recent draft guidelines are recommending that currently we are working on limit state of serviceability and limit state of collapse or strength, but the new draft introduced 6 limit states, and one such limit state is limit state of durability. So under limit state of durability, the code is actually recommending every concrete that is going to be designed or every structural element that is going to be designed should be checked for acid attack, sulfate attack, chloride attack, carbonation, and water permeability or penetration. Acid is not mandatory, but the chloride, sulfate, and the carbonation code is making it mandatory, and they have given the procedure also. So right now, when code is recommending such sort of process before taking a call on what element should be designed, that plays a very important role in terms of application. Now, we talk about sustainability in terms of materials, but it is also important for us to understand which material among all these materials has got a fantastic durability down the line. And for that to happen, we don't have structures. See, we're talking about high strength concrete, but we don't have structures built with high performance concrete, high strength or ultra high performance concrete in order to have the statistics. So right now we are only focusing on material. Later we will see what are the other parameters to be considered for sustainability. So another important aspect is the aggregate replacement materials and their properties on concrete. You can see there the construction demolition waste or the crushed rock fines or the waste foundry sand, bottom ash. So what are the materials that can be used as both fine as well as coarse aggregate is what we are seeing right now. almost every material can be used as fine aggregate, but not all materials like waste foundry sand and coal bottom ash, including the crushed rock fines, they cannot be used as coarse aggregate. They can be used only as fine aggregate. And you can see the specific gravities except for the e-waste, and there is nothing much, almost every material is within the similar specific gravity range. And water absorption also is high for, POC, which is because, palm oil clinker and it will absorb water. So that's why the percentage is higher. But when it comes to every other material, like as I told you, it's actually viable to be used. Fineness modulus is also good within the limits as per IS 383 guidelines. And you can see almost except for palm oil clinker, every other material declines the workability part because nothing could beat river sand. Even though we say river sand is, when we use river sand, the natural sources will be depleted, but the process is inevitable and there is no control over that. So different percentages of replacements were given here. Strength, of course, it doesn't matter much, but depending upon the dosage, the strength and durability will keep on increasing or decreasing. So the e-plastic waste, which can be used both as fine aggregate and coarse aggregate, has not got very good results, especially when it comes to the properties. So that's why I told you construction demolition waste, crushed rock fines, waste foundry sand, and bottom ash, they are the popular materials which can be used without any interruption or without any second thought, right? So you can also see one tentative analysis done by GCCA and the Portland Cement Association that how does the blended cements perform when compared to the conventional part. So you can see OPC, PPC, PSC, and composite cement. PSC consists of slag, and you can see 57% slag and 38% clinker. Gypsum is constant throughout, but the fly ash and slag percentages were varied. So if we are trying to look into the reduction in the carbon footprint, you can see 740 for OPC, but when it comes to the Portland slag cement, it's just 304. Again, same is the case with energy consumption, whether it is thermal energy or electrical energy. All the other types of cements are better compared to OPC, which means that it is high time that we start adopting Portland Pozzolana cement or Portland slag cement or composite cement, where we have got codal books or the Bureau of Indian Standard guidelines for each of these things. I think we shouldn't have any second thought. Now, other challenge is to obtain pure ordinary Portland cement. Pure OPC availability is a very big challenge, and that makes life very difficult these days. So most of the constructions have also started moving towards the blended cements for a better sustainability practices as well as economical construction. So now other thing which I am very much focused on. So these are some of the researches that have been carried out by one of my good friends and current head of the department, Dr. Bahruddin, from BITS Pilani Hyderabad campus. So he and his team for the last 8 to 9 years have explored tremendously on agro waste. And he is one such fantastic potential who has got a lot of scope in, who has created a lot of scope in agro waste materials and its utility in concrete. So the next two slides I've taken from a couple of his papers, and you can also refer to them. I've given it as a reference, and they're fantastic papers, and you can understand what they could do. So right now, if you see the processing methods, one of the major advantages of using sustainability term in developing low carbon materials is the processing with which it has to undergo. Any material. So the question is, can any material be converted to a material which can be used in concrete, which has got cementitious properties? Answer is both yes or no, and that depends on the process with which it undergoes, in terms of treatment. So you can see here, there are multiple materials that you can see on the screen right now. One is sugarcane bagasse ash, rice husk, you can use corn cob, wheat straw. Every material of such nature will be converted to a residual ash, and then we need to see whether the pozzolanic reactivity is sufficient or not. If the pozzolanic reactivity is sufficient, then you can directly use it. If not, it has to undergo any one of or the combination of mechanical, thermal, or chemical way of treatment, or thermomechanical treatment combination, or it can be thermochemical also. So what is the meaning of thermal treatment? You need to heat the waste that you have extracted between 500 to 700 degrees with a suitable, pozzolanic activity index greater than 75% and loss of ignition around less than 10%. If you are trying to adopt the mechanical way of treating it, you have to adopt by sieving or grinding, and then when you are trying to do that, it has to happen with a particle size less than 15 micron. You can also treat the material with the help of some chemical means by soaking it in the solution HCl to H2SO4 or H2SO4 for 60 to 120 minutes. And of course, chapel activity should also be followed, or you can adopt any of these combinations, either thermomechanical or thermochemical. So this will lead to waste reutilization. It will minimize the greenhouse gas emissions and reduction in waste disposal and land pollution. Land pollution has also become popular these days, and it will also lead to sustainable construction also. So you can also use other materials which can be considered and abundantly available in our country. Tobacco waste, the cassava, we call it a sweet potato. So when we use sweet potato, the peeling of the sweet potato should be removed. You need to peel it off, the top layer, convert it into an ash, and even that can be used. So the process remains the same as I told you in the previous slide. So these are all some of the examples of different agro waste where you can come across and still start using it in the concrete. Either practically it requires a lot of approvals, but for small scale elements like small portico or facades or some outdoor elements or inside planters, footpaths, you can try these things with paver blocks or bricks or any of these things. And then other thing is, this is a very important slide for all of us, that how actually do we need to pick the right choice of material that leads to sustainability. So this is a triangle that talks about, towards the left hand side we have calcium and the other alkalis, including the magnesium part, and you can see at the top silica, and on the top right bottom you have alumina and iron oxide. So how to pick the sustainable material? Any material which is rich in silica, alumina and iron oxide, or towards the right hand side if you keep moving, those materials are actually sustainable in nature. Any material which is close to CaO and the entire part, then it is not sustainable because it is rich in calcium and it requires processing. So LL is limestone filler and it is tremendously rich in calcium, magnesium and the alkalis. So it's not sustainable. Portland cement stands somewhere here, but you can see different materials, steel slag, somewhere between all three, silica fume towards the top, bauxite residue is rich in alumina and iron oxide. So you need to pick some materials. You can see fly ash, class C, class F, siliceous and calcareous. So fly ash, siliceous, you can see it has got blend of all the three combinations. So if you are trying to pick a material, this triangle should be used as a reference, and you can pick it and start working or developing suitable concretes that are actually leading to sustainability. Now, currently, these are the materials which we are using, and emerging materials. So you can see whether it is a reactive material or inert material. And you can also see emerging materials, biomass ash, it has got fantastic scope. Ceramic waste is one, recycled glass, as I told you, calcined clay. So these are all having tremendous heat release and the bound water requirement also. But the future is all about steel slag, municipal solid waste ash, bauxite residue, and the important thing is the NFM slag. It has got a very good application, and it has got the non-ferrous metallurgical slag, and it is a byproduct of metal smelting. So when you are using it, it will give you fantastic results, and wherever you get it, you can start using it in concrete. So this is the future of sustainability in concrete. Now, with a very basic understanding of different low carbon materials, now I will take you through some of the key environmental impacts during the life cycle of a building. So first, we should not think that sustainability means material only. As I told you, I told you multiple times in the presentation also. Sustainability is a parameter that starts from the extraction of a material toward the entire life cycle of a building. So you can see during extraction, you will get some harmful pollutants which will impact the climate change. And again, during manufacturing of the material, it will lead to acidification because of these pollutants. During transportation and construction, it will lead to eutrophication because it requires energy, fossil fuel, and water resource. And after construction gets over, during its usage or during retrofitting time, ozone depletion is one possibility. And then we have energy fossil fuel, which we generally talk about human health damage. It will during disposal time. And lastly, during recycling also, you have environmental impacts. Meaning at every stage of the building, starting from material extraction, material manufacturing, element transportation, and elements construction, during its utility or disposal or recycling, there are tremendous environmental impacts, right? So let us see. I was talking about reduction in the embodied carbon. So what is embodied carbon, first of all? So there are different definitions given. First, I'll start with the embodied carbon network. It's a famous platform. It's a sum impact of all the greenhouse gas emissions attributed to the materials throughout their life cycle. So they're talking about materials, right? Any process. World GBC also defines the embodied carbon as the carbon emissions associated with materials and the construction process throughout the whole life cycle of a building or infrastructure. So combination of both. And there's one more magazine called Circular Ecology. So the Circular Ecology also defines the embodied carbon as the carbon footprint of a material. So it considers how many greenhouse gases are released throughout the supply chain and is often measured from cradle to grave or gate or site. Okay. Right. So why do we need to focus on embodied carbon? Now, this is very, very important. Most of us will think, why at all it is required for me? I don't need to use it at all. Fine. But see what the statistic says. So by 2060, the world is projected to add almost 230 billion meters square of buildings, which means whatever the current global building stock you have, that much area is going to be produced in the next 35 years. That is dangerous. Which means this is equivalent to adding one entire New York City to the planet for every 34 days for next 40 years. So imagine that every month we add a New York City to the globe. And imagine how much amount of construction is going to happen. That's why embodied carbon plays a significant role in construction. So to understand what is carbon, there are two categories. One is embodied carbon, the other one is the operational carbon. Embodied carbon is because of the manufacture, transport, installation of construction materials. And operational carbon is largely because of the building energy consumption. So building energy consumption is different compared to the utility part, right? So now let us see how both of these would impact. So that's where we will try to understand operational versus embodied carbon in buildings. So operational part is pretty straightforward, wherein it depends on the utility of whatever we have been using in our day-to-day routine. Electricity use, energy use for heating and cooling, or on-site fuel combustion. But embodied carbon, as I told you, it involves like the entire whole process of manufacturing, construction, and materials also. You can see the right-hand side graph that talks about the gigatons of carbon dioxide emissions. So, so that's very important. And believe me, there's no building sector interventions here. Yeah, so 57% of the embodied carbon, you can see there by what happens, the significant increase. 43% goes to the operational carbon and 57% to embodied carbon. And see what happens here, right? You can see that the upfront embodied carbon, product plus construction, annual operational carbon is this much. And by 2050, it's going to see a tremendous increase if we are not addressing it properly, right? So that is dangerous, and that's one of the main reasons why we need to consider the embodied carbon. The net zero buildings or zero energy building concept also would be derived from such concept. So that's where we also have to ideally understand that apart from materials, it's the operations that plays a very important role, right? You can also see some example here, the standard performance building and high performance building. The high performance building annual emissions of carbon dioxide are comparatively less to the standard performance building. And embodied carbon rating also you can see here, right? Now, so as I told you, the emissions occur along the supply chain. So upstream and downstream, if you pick it, so that's how it works. So now you can see here embodied carbon, raw material manufacturing, the whole process I've already explained, and this is operational part. So this is the life cycle of the embodied carbon. So this is how we need to talk about like raw material extraction. So it's divided into four categories: A, B, C, D. A talks about, you can see here A, B, C, D. 1 second. Yeah, this one. Raw material extraction, supply, transport to plant, whatever cycle I have shown you before, same thing is again displayed, but in a better way of understanding the embodied carbon. Now, I would want you to focus here, the B6 and B7, predominantly that's where the operational energy will come into picture and operational carbon will come into picture, right? As I told you, you can see this also, the embodied carbon and operational carbon. So during operational water and energy, so where do we get operational carbon and water? That's during the utility of the construction. Okay. So now, building sector is responsible for 39% of overall energy-related global CO2 emissions. You can see that here. The transport sector, and it's drastically very high. And building materials contribute to 11%. And that's not wise, isn't it? That's not fair also. So now if you see the cradle to grave analysis, the product during the production stage itself, there is a 50% contribution of the carbon, and it comes down to just 5% during transportation, construction, and installation. But during the utility, it is almost 43%, which means in this 43% only we have operational carbon. So what do we understand? Something that is associated with the manufacturing itself is a critical role, raw material supply. When we cut short that, that's why we talk about locally available materials. It is always recommended to use the local available materials for construction. That's the best thing and the best solution also. So this is taken from literature like residential buildings and its embodied energy for million joules per meter square. You can see a construction with, you can see the maximum embodied energy is seen in RC frame and burnt brick. Concrete and timber with trom wall also led to higher value. RC and the brick with sun space and trom wall is super high. But it is very less for wooden log house. If you use wood, stone, soil, cement, brick, and then log house, brick masonry and RC slabs. These are all some of the values with some of the types of material used so that the embodied energy will come down. On the top of it, we also get a doubt. So why I'm showing all these things is because zero energy buildings, people are talking about it, but when it comes to implementation, it's a big challenge because every component of a particular locality or a building should be zero energy based. And that's not easy, right? So right now I can simply say, I'm talking about sustainability. And if I switch on the air conditioner in my room, gone, right? That's not sustainable. Okay, that's why I'm talking about all these parameters. Now, when you're talking about the transportation sector, in terms of transporting some of the construction materials, you can see predominantly the energy super high for production part, especially for burn clay, brick, Portland cement and steel. They are not sustainable. You can see more than 500 million joules per unit. But when it comes to crushed aggregate or sand, hardly you find any production energy. Transportation energy for 50-kilometer travel and 100-kilometer travel might be high, but definitely not the production energy. 42,000 for steel production, believe me. Almost 6,000 million joules of, per unit for Portland cement production, that's threat, right? You can also see here some of the waste factors for some of the materials. Now, okay, embodied carbon is good, but how do we calculate it? So one of the simplest form is embodied carbon is equal to quantity of the material or anything in utility multiplied by the carbon factor. Simple. The fundamental principle of embodied carbon is typically to multiply the quantity of each material or product by a carbon factor, and it is measured as kg carbon dioxide equivalent per kg of material. Okay. So for each life cycle module considered, there are different modules that I have shown you before. So for each life cycle module, it will change. Embodied carbon is equal to quantity multiplied by carbon factor. So I will take you through one of the interesting stuff here. One example. This is taken from, it's a very good guide. A brief guide to calculating embodied carbon. And you can see this here, that this is a document, and whatever I have shown right now are taken from this only. They have taken example problem of a building, and they have given the tables for embodied carbon factor. ECF means embodied carbon factor. So quantity multiplied by factor, right? I will not explain the complete example, but I'll show you an example. So this code, this document says at different levels. So for each of the material, let us say for concrete, and if I am going for reinforced concrete with 150 mm hollow core slab, then 50.2 kg carbon dioxide emission per meter square is emitted. This is as per the data source. If I use reinforcing bars, 0.684. If I use unreinforced concrete with 75% GGBS, it is 0.063, which means type of material, you see brickwork, blockwork, timber, plasterboard, or different paints. For everything, they have the carbon rating values, carbon factors, emissions, how much. So similarly, we have it for transport emission factors. For different modes of transport, you can see road, sea, freight, and rail, and what is the equivalent amount of the carbon emitted. And different transportation scenarios, locally manufactured, nationally, European, and waste factors for typical structural materials. So for each of the materials, what is the waste factor? So what they have done is they have taken this building with plan, and they created an Excel spreadsheet to calculate the embodied carbon. You can see this is a step-by-step process of calculating the embodied carbon. And finally, they have given that the total embodied carbon is equal to 185 kg carbon dioxide equivalent per meter square of area. And the carbon that got sequestrated was 123 kg. So this is a step-by-step process, and there is a mechanism to do it. This document, I'm again showing it to all of you with a solved example, a brief guide to calculating the embodied carbon, right? So I would want all of you to please look into it. And it's a fantastic example they have given. So coming back again to whatever we have seen, okay, manual calculation is fine, but is it possible to do it online? Can we calculate embodied carbon tool online? And the answer is again yes. You can see the website that I'm taking you through. This is called as an Edge app. This Edge app actually talks about you need to log in with your login credentials. You need to have your login ID and password, and then automatically it will provide you with suitable details that you are looking at. See here. So this is the website, EFC, International Finance Corporation, for the calculation of embodied carbon. So when you are trying to look into it, you can see what you will actually see here. This is the window for you. If you want to do the embodied carbon analysis for apartment, service apartment, hotel, resort, any type of a building. If you want to do it for an apartment, okay, apartment. And in this, what is the design detail criteria? It's pretty slow because it has to process, and it will take some time. So it will ask us for what is the type of a building. So you have to pick the type of a building as apartment, and that's already been picked. You can also pick the location. You can use this tool anywhere across the globe, but I will tell you it will take some time to load. So when you perform the analysis, don't submit. If you submit, it will be stored in the database. You just try to get the values of your choice. So right now, I am picking India. Okay, and it will again process, and it will give different cities in India after that. Yeah, so let it run. So right now it has started giving cities in India based on the alphabetical order. So you can input everything based on the life cycle of the construction. That is the advantage of this tool. It takes time, but definitely worth the time. So I'm not, again, you can see here, I will pick Hyderabad as the city. Again, it will process, right? So then once the design is, once we pick the type of material and subtypes, then automatically it will take us through different types of topologies, number of floors, and then what is the aggregate roof area, number of floors required, what is the total area, what is the utility of water, building dimensions. Every information you can actually define based on your choice. That is one very important. Or you can pick a material of your choice. You can see here material, and in the material, it will actually ask you what type of material you are using. Proportion is 100%. Let us say thickness, I'm giving 100. It will again calculate steel bar kg. If I say 100 kg per meter square, I'm giving rough values. So these are all default base materials. So I can say I wanted a concrete slab with 25% GGBS. Then you can see automatically what will happen is your values will come down. This 383 is the final embodied carbon. Those values will come down when you submit for analysis, right? If you click calculate and save, those values will keep coming down, which is a very good important aspect for us, right? So I should give input all these things, and if I click save, of course, it is asking me to enter every parameter here. So I need to enter all the materials of each of the component of the building. You see here now, the embodied carbon value has come down from 383 to 295 because I have used slag in one of the element of the construction, right? Right. So now again, I'll take you through the. Just a second. Yeah. So again, I will take you through this. Sorry. Yeah. So this is what we have seen, a website of how to use the, how to calculate the embodied carbon based on the inputs that we give. On the top of it, we also have a building energy code. You can also have an access to it. You can look into it at your leisure. EC BC 2020 Econivas or individual states has got their energy code. You can refer to that. Now I'll quickly rush through. Now we have seen the embodied carbon. It gives us an understanding that we have to use low impact materials and low carbon materials. Okay. Right. So where all it should be used? It should be low in energy for production, low water usage, low resource depletion. It should be easily recyclable, low embodied energy, and made of recycled content. That's what we call as sustainable material. So where all we can find this? So during design, you have to optimize. See, optimization of the sizes of the building. Your windows and doors should be properly provided for extra ventilation, that is natural lighting. Your facade elements can be made sustainable with glasswork. And during design, you can also talk about the life cycle assessment or life cycle cost. And during construction, you need to ensure that the waste is reduced, waste is reused, and waste is recycled. And while procurement, you need to use green purchasing or procurement techniques. In tendering only, we have to take a call that that the construction should follow the green guidelines, accredited materials, and local available materials, as I repeatedly spoke about. Of course, life cycle assessment, you're all aware of this right now. So one has to adopt waste to wealth strategy. You eliminate at the source, reduce, reuse by the supplier, recycle by negotiating with the supplier, and recovery. This is how the procurement hierarchy would happen. And this is the waste hierarchy. It's a 5R principle: reuse, recycle, reject, repair, and reduce. So some of the interesting guidelines or interesting tips for all of us. Waste concrete can be constructed, can be casted to a concrete block. These are some of the tips. Big boulders can be used as a manufactured sand by crushing. Steel scrap, which we throw it as a waste, can be used in construction of lintel or drain cover. Excavated soil can be used in making bricks. Broken tiles and paver blocks can be used in terrace construction work. The construction debris can be used in making road bases. So this is waste to wealth strategy. Another important thing to make our buildings, zero energy or reduced embodied carbon energy is by providing a suitable window to wall ratio. This is one of the projects from Pune taken care by L&T called as the Nextra project in Pune, where you can see that there is a tremendous reduction of 15.38% of the overall environmental impact just by reducing the type of materials that are used and the wall to window ratio, and adopting suitable sustainability initiatives in the construction, right? So this is the base case and this is the proposed case. There is a tremendous reduction. One has to reduce the cost. Initial cost plus future cost is life cycle cost. We should not only consider initial cost. In the future, maintenance will be there, operations, downtime, consumption, everything should be considered. It's better to use LED fixtures compared to conventional fixtures, or CFL lamps are also coming into the market, and the cost accordingly will come down. While procurement, these are all some of the standard ratings or some of the platforms where our material can be, our material or product will be certified. These are all certifying agents, okay, for carpet, for wood, or for electricity, or for material, or for a product, everything. So this is the Gruha catalog. Gruha is India's top-rated sustainability rating organization, green rating for integrated habitat assessment, and they are doing a fantastic job. So now it is also necessary for us to actually look into Green Pro certification. So every product through IGBC, through LEED or Gruha, IGBC is doing a fantastic job again. Of course, when we buy a refrigerator or when we buy a TV or geysers or lamps or air conditioners, we actually look into 5-star, 4-star, 3-star rating. That means they are power saving, and this is defined by Bureau of Energy Efficiency. Like that, it is applicable for wood also. Carpets, they are certified for sustainability. Logos, eco logo for sealants and chemicals and admixtures. And then for floors and tiles, in order to satisfy the indoor air quality, floor score certification is given. Formaldehyde acetaldehyde, and whether the presence of cancerous materials or chemicals are there or not. They are very important for sustainability. Environmental product declaration is also important, and it plays a significant role. And it's necessary that we use low impact construction materials like conversion of paper to waste, like paper to papercrete. That is one option. Green energy bricks with polyisocyanurate foam. It's a very good material which can be used for energy. And the R value is 8+ for green energy bricks, which is a fantastic achievement. You can use pervious concrete where you can reduce the sand altogether. That is very important. And of course, aerator in taps, fly ash bricks, LED in common areas. So this is all about my presentation in brief about what are all the materials, how to get the certifications for each of the utilities inside the building, how to calculate the embodied carbon, and there's a website to calculate it. Now I'll end my presentation by taking you through some of the sustainable and smart initiatives at Mahindra University. So I sincerely acknowledge my collaborators, in fact, Professor Visalakshi, some of the works by Dr. Ataul Khan and Dr. Jaiprakash, whom we have been working for the last 4 years, and largely the Smart and Sustainable Material Lab. One of the leads for that research lab is Professor Visalakshi. So we have, and our PhD students and postdoctoral fellows and interns as well. So they have contributed a lot in developing many materials for the last 3 years. So what all you are seeing is, what we have achieved in the last 3 years, and that can be, alkali activated concrete, that can be, damage assessment of aluminum balls. So we take care of developing sustainable materials as well as smart materials through sensors. So we have developed concretes of grades from 3 megapascal to 150 megapascal, and we developed concrete of densities ranging from 300 kg per meter cube to 2,500 kg per meter cube. Some people will say concrete cannot be molded to different shapes. We made C-shaped section, curved shape roof, curved shape roofing panels, or different shaped panels. We have converted the waste from mining to bricks, waste from the slurry to bricks, and waste from municipal solid waste also to bricks. Some of our students have also got awards at the competitions organized by the Government of India and IIT Bombay and at many other places. And you can also see here, these are all, we have not restricted ourselves to laboratory. We also started developing products for wall panel, boundary wall, compound walls, slab elements, and we actually started marketing as well. So we have taken the product from lab to market. So this is also one of the projects with IIT Delhi. Professor Visalakshi has got this project, development of fiber reinforced bamboo composites. This particular setup is for a shake table, and it has passed an earthquake of magnitude more than 7.5. And we got very good support. And then this is the construction happened with bamboo reinforcement. So all the structural elements are constructed with bamboo, and the walls are constructed with cow dung, that is called as gocrete. Not only this, one of our PhD students visited Portugal to develop 3D printed concrete for multiple applications. There they have used biomass ash, nanoclay, kaolinite, and superplasticizer. So these are all some of the 3D printed samples at Portugal. And of course, we have our student startup at Mahindra University where they have developed 3D printed concrete specimens, and we also have got a large scale 3D printer of size 1.5 meter cube, and it could print up to 2 floors height. Right now, we have around 4 interns working on it from various engineering colleges. We have collaborators from multiple universities, and we have a dedicated PhD student working on this. We also developed sandwich panels at the factory. You can see the sandwich panels. These are all precast in nature. We have our own startup thanks to our PhD student who has developed a lot of products. You can see this is U-Drain, which uses again sustainable materials. We got a patent granted out of it, and again another patent granted for the dual reinforced concrete panels, and the third patent as well for developing the high performance lightweight composite panels with required sustainable cementitious materials. So once again, I thank all of you for your patient hearing. And I would again thank the organizers for giving me this opportunity to speak about the sustainability through materials and the embodied carbon. Thank you once again, and I'm open for questions.
Thank you, sir. Thank you very much. It's a wonderful session, sir, and so much informative.
Thank you so much, sir.
Yeah, it's seriously, very wonderful session, sir. I hope our participants also like that. So now the chat box is open for queries. All participants, you can post your queries in the chat box.
Yes, and I will also share my email ID in the chat box if have any questions, or if you want to interact with me, or if you want to send your students for internship and all. I'll be more than happy to respond to the emails.
Yeah, thank you very much, sir.
And if you have any questions also, you can post in the chat box, or you can raise your hand, and so that the organizers will unmute you and you can ask directly.
Participants, you can ask questions from through the chat box. Sir, one question arrived.
Yes.
Sir, we have incorporated waste biomass in material product.
Yes, it did not happen directly in India. This is a part of one of the collaborative work with Portugal, where our scholar visited Portugal, and there they have used biomass ash as one of the potential material in making 3D concrete printed products. And so we have used it. And in fact, I will tell you one thing, that the biomass ash is actually not a separate entity. It is as good as any ash that is available in the market. And I can tell you, it can be from industrial waste, agro waste, municipal solid waste can also be a biomass ash. So we tried working with cardboard-based waste material at Portugal, but when he has come back, it was found to be very difficult for us to get the same product in India. So yes, but definitely biomass ash has got very good scope in the future. I hope I have answered your question, Abhay Kumar from SVNIT.
Another question, sir.
Yeah.
Sir,
Electrochemical treatment of hazardous leachate. Can you suggest me products, my end products less useful? Oh, okay. So you are wanting to convert the sludge. I have not explored it, but one thing is, okay. First of all, electrochemical treatment is a good option for the hazardous leachates, but when it comes to the sludge, one option is thermal treatment, because I've seen people using sludge waste in concrete. I have personally not used it, neither our team members also. But one such option is the thermal treatment, where you can heat it and extract the required pozzolanic reactivity and then start using it. I mean, I can explore. I can just talk to some of my peers and get back to you on that. I have given my email ID. You can write to me on that. As of now, thermal treatment is a wise option. Yeah, I could say that much.
Okay, sir. Thank you. Another question. Idea for sustainable technology. Exactly. Thank you for valuable comments.
Thank you. Thank you, Abhay Kumar ji.
Participants, you can ask questions now. The chat box is open.
Okay. Happy Holi to you. Okay. Reducing the greenhouse gas emissions, and can you just throw some light on what is okay? Net zero building. Okay, fine. So when you are talking about the net zero building, as I told you, the whole process involves implementation of zero energy buildings across the entire building. Sustainability is automatically achieved. Why I'm telling you that is because if you see the whole process of the idea of the net zero energy building concept, you have an insulated roof material which has got less thermal conductivity. You have insulating wall panels there. and you'll also install some kind of solar or thermal systems on the top of the roof. You have all your windows and doors with appropriate thermal conductivity again, and your architecture is also bioclimatic architecture. So which means largely, and you use some sensors to automate certain things, because the entire process is about implementing multiple parameters. Definitely there is no direct way of emitting the gases to the atmosphere, so greenhouse gas emissions will come down, and obviously it will benefit the climate change. I hope I have answered your question.
Another question arrived, sir.
Yeah. Okay, Atish, there is one more question. I'm extremely sorry, I've not come across lignin or anything relevant to ethanol. No, I'm sorry. Net zero building energy. Net zero energy building codes or zero energy building codes. As such, there is no standard for that, but every country has got their zero energy policies or carbon codes. ISO has got it. ISO has got a code for zero energy buildings. I will message you in the chat box right now. So they talk about residential as well as non-residential. ISO for ISO 270. I'll message you in the chat box. There is a code from ISO. I don't remember the number, but I can say that there are ISO codes. ISO codes for net zero energy. I exactly don't remember the number. Yeah, I think I've answered the question of Vivek ji. Well, that's an interesting question actually. Lignin produced as a byproduct from ethanol, it has got a good scope, and I totally agree that it is too good. Yeah. Any other questions?
Any other questions, participants? You can post here in the chat box.
For doing research on carbon footprint, which cement is to be used, OPC or PPC? I mean, the question has the answer also, because you would want to work on carbon footprint, which means the ideal choice would be PPC. Ordinary Portland cement manufacturing process is not sustainable. Okay. Any other questions from anyone?
Any other questions you can ask? So, next question.
Carbon capturing and carbon sequestration. That's the future, I can tell you. There are actually, I thought of actually adding some of the ideas which we started working, but because of the confidentiality or because of the ideas, I could not speak much about it. Yes, carbon capturing is definitely possible, and there are some investigations that are happening, and even we also have started recently on carbon capturing, especially not sequestration in detail. It has got a fantastic scope, and even carbon curing. There are very good websites like the industries who are adopting to carbon curing. There's one website on carbon cure technology only. They are giving a lot of information on that. But when it comes to carbon capture, yes, it has got a very good scope, and basic preliminary results have also shown a lot of encouragement, and there is a good scope also. We actually are working on one of the projects which requires carbon capture and carbon capturing. We need to see where we end up with. But yes, it's a good future.
Any other questions, participants?
Biochar is recommended as carbon-rich material, but its dosage is, but its effect strength less. Can it be added in concrete for mechanical? And yeah, that is again a very good question. See, I told you example of rice as cash. This rice as cash. The problem is, India is rich in rice production, but because of the consistency of the availability of the material, and it is carbon rich. But the challenge is it is limited to be used below 7%. And when you have rice as cash with fly ash, strength will come down. Now, when it comes to biochar, as you rightly told, the maximum dosage is not more than 2% also. In papers that I have read, 2% or 3%. But largely, what is the motto of using it in concrete? If it is purely sustainability, then let it be. Let other materials take care of strength and durability. Let biochar take care of sustainability. It's a win-win situation. Most of the times we think that whatever material I use, it should increase the strength, it will enhance the durability. Not necessarily required. Today we can use binary mixes, ternary mixes, quaternary mixes. So 4 combination of materials when we are using with lot of, even it's not easy, but people are using it. So let other material take care of the mechanical and durability part, and the materials like biochar, let it be used for sustainability part. That's there is no wrong in that. And another thing, the way it is processed also plays a very, very important role. And if it is processed effectively, I think your dosages can increase. Sunita Sarangi, so madam, you can ask what is your question on that. What is your question related to this? You said you have a question on about operational carbon and embodied carbon does affect same problem for material. Oh, sorry. Okay, got it. No, embodied carbon is only for materials. Operational carbon is during the utility of power consumption, water consumption. That comes as operational carbon. Embodied carbon is only associated with materials. Materials, products, or any other process. Operational carbon means during utility. That is only during utility. I hope I answered your question. Okay.
Thank you, sir. Thank you for seriously wonderful session.
Thank you so much.
So before going to end the session, our coordinator, Dr. Imdadullah sir, have some points for the participants. So thank you, sir. Thank you for the session, sir. It's a wonderful session again.
Sure. Thank you. Can I leave, sir?
Yes, sir.
Okay. Thank you, participants. You can write to me for anything. I've messaged my email ID. Thank you.
Okay, sir. Thank you very much. So, Dr. Imdadullah, sir, I'm audible to you?
Yes, sir.
Yes, sir. You can carry on, sir.
Yes, sir. Yes, sir. Dear participants, tomorrow at 6:30 we have athlete test in Google Form. Already I shared one ID, participant ID, in our WhatsApp group. Please go through it. While entering this Google Form, please register your ID, participant ID. Without a participant ID, your marks will not consider. Okay. So it's take half an hour time, total 25 questions, 6:30 to 7 p.m. If you are absent in this particular test, even though you attended full section, you will not generate, you are not eligible to get your ATAL certificate. We have huge number of participants, so we need some time for 4 to 5 working days to submit our attendance sheet and test evaluation sheet to ATAL, so that we can, after that we can get some feedback, ATAL feedback in your portal, participant portal. You have to fill that participant feedback also. That is mandatory from ATAL. If you are failed to fill this feedback, which is appear in your portal, you will not get your certificate. Am I clear? See, dear participant, tomorrow we have online test in Google Form. The time is 6:30 p.m. to 7 p.m. So for that we are sharing one PID, that is participant ID. Already it is shared in your WhatsApp group. Please go through it. While starting your exams, online test, before that we have to register this PID name, then your designation, email ID, then your institution details. After that, you have to start this online test. That is mandatory. Okay. Each section we are sharing some feedback form, that is for our references for participant attendance register. Already your section is registered tracking through this Google automatic attendance register. This one is feedback is taken for manual attendance register. The two our feedback assessment also, our documentation purpose. Then after we are submitting this, we need some time for the submission of your attendance and your online test assessment. It will take 4 to 5 working days. After we are submitting this to ATAL FDP, you will get one feedback from your portal, through your portal from ATAL. So that is for ATAL. You have to submit this. If you are failed to submit, you will not get this certificate. Am I clear? Okay, hope all are enjoying this sanction. And that too, Jalal sir is cooperating and coordinating. Thank you, Jalal sir, for your.
Thank you very much, sir. It's a teamwork. You are also doing same like me. So before end of the session, please open your cameras, participants, so that we have a photos as a total requirement. And before end of the session, I need to clarify one thing, that tomorrow there is a 6th day. There will be 3 sessions. The session start from 2 o'clock and it ends at 6:30. So there are 3 sessions. 2 to 6:30 there will be 3 sessions. 11, 12, 13 session. After that, 1 hour is for your online test. Then after completion of your online test, the half an hour will be 7:30 to 8 o'clock. There will be a validatory function. In that, the management and the dean and the research dean and our HOD sir will have some words on the FDP. So you should present tomorrow as well. And the session starts tomorrow at 2 o'clock afternoon sharp. Okay. And it's really commendable. Even the today is the festival. Even though the participants have been maintained their attendance, it's seriously commendable. So I congratulate all participants. So before end of the session, please open the cameras so that we have our photos for ATAL requirement.
Jalal sir once confirmed with all the participants that everyone is clear with the tomorrow exam and tomorrow that.
Yes, sir. Our coordinator, sir, Dr. Embodied sir, has cleared all the doubts, sir, from start of the session and also in the end of the session. Participants, please open your cameras.
Please active camera and please mail also. Okay, done. We will be sharing the mails.
Tomorrow's section start at 2 p.m. Please join.
Yeah, tomorrow's sessions. Tomorrow there are 3 sessions. 2 are national speakers and 1 is international speaker again. Then afterwards we have test. So those 3 sessions also very important. Maintain same attendance like this. So hope you all clear about all instructions. Please note down the points. The sessions tomorrow start from 2 o'clock.